Hi there. Today we'll look at SingularityNET, the global AI marketplace, as it is advertised on their website. Specifically, we're going to look at the SingularityNET Whitepaper 2.0 as it appeared in 2019. So it's version 2. Version 1, I think, appeared in 2017. So SingularityNET is as it says, a global AI marketplace, but it is also kind of an effort. It is a foundation. It has blockchain in it. It has AI in it. It has symbolic computation. It has graphs. It has all the things, all the buzzwords you could possibly want. So the high-level summary of this system is that it is a marketplace for APIs, basically, on blockchain, where either humans or APIs can call other APIs and pay them for that service. And the goal is to sort of get a network going of APIs that call APIs that call APIs, and sort of have that build into a global AI, not only marketplace, but like as itself a global AI. This is backed by the SingularityNET Foundation, and they do a whole bunch of development of the platform, but also research on the platform. And we'll look at all of this today. So it is a white paper, which is not a research paper as we usually look at. That means a bunch of things. First of all, as you can see, it's quite long, and we're going to skip most of it, actually. But also, maybe it's just because it's a white paper and that's usual, but all of this it's sort of marketing-y, and it's sort of never fixates on one level of analysis. Like, it goes into this and then a bunch of buzzwords and then super detail, and then it talks about, what kind of cache do we need for the database, but then it goes back and it just references a bunch of stuff without explaining it to just kind of beef it up for investors, I guess. I don't know. In any case, we're going to go through it. We're going to go through what the marketplace looks like, how it works, what it's good for, some of my criticisms. The central components, as I said, are the APIs, but also a rating system, and it is also decentrally governed. So the goal is to have the community govern the network. And lastly, the goal is to have all of this be beneficial for humanity. So we're going to see how this all ties together. So what's the current situation, and what does SingularityNET want to do? So let's say you are this external software. You're a person, okay? And what you want to do is you want to summarize a document. The view that this system has is that you could give this to a document summarizer. The document summarizer, however, looks at this and sees, oh, what are you giving me? You're giving me, and in this case, it might be, an article of the New York Times that has both text and video. Okay, so you give it, you see an article, it has like a title, it has a bunch of text, and here it has like a little video to go along with it, and you simply say, summarize this to me. So this document summarizer, all it does is it looks at the document and it sees, there is a bunch of text and there is a video here, and I'm going to so in order to summarize the document, I need to summarize the text and I need to summarize the video. So it will take the text and it will send it to a node that's dedicated only to text summarization. And then it will send the video to a node that's only dedicated to video summarization. The video summarizer in turn could do stuff like call face recognizers and call some databases in order to sort of get who is in the video or what's in the video. It could call object detection and so on. The text summarizer, in turn, it could call some word sense disambiguators. It could call entity extractors to also realize what is in the document. And then these nodes will send so every node can call other nodes in the network. And at the bottom, you'll have these sort of AI primitives, like face identification, entity extraction, and so on. And they are not meant to be called by you directly. They're meant to be called by higher level nodes that sort of aggregate them. Okay, and this, now if you look at this, and if you are a software developer, you think of libraries. Like you think, of course, this stuff here is, maybe that's Hugging Face, and this stuff here probably in Spacey, that exists, right? If you are a software developer, if you have to do subtasks, someone probably already solved that subtasks. I can just call a library. Now, the view of SingularityNET is that no, maybe you don't want to call a library. Maybe you don't know yet what's the best. So their view is a marketplace. And why is a marketplace better for AI than for regular programs? Because for regular programs, we don't need a marketplace. We simply call a library. Why is that not good for AI? And I'm trying to sort of make sense of this right here. I am not convinced by this system either, but I'm sort of trying to make the best case for it that I can. So if you are this, let's go back to that graphic. If you are this text summarizer and you need to do entity extraction, right? You might have a lot of choice. So there might be, entity extractor A, there might be entity extractor B, and so on. There might be many of these entity extractors, and then a new paper comes out, right? And then entity extractor F is somewhere on GitHub, but so what you need to do every time a new entity extractor comes out, is released, someone makes a paper, maybe puts some code, the code doesn't really work, you have to go fetch that code, you have to plug this into your system, right? You have to test against your data sets, and you have to decide, is this better than what I had before, or is it worse? Is it worth including, and so on. So it is in the classic software world. If you have a library that does something, it does that thing, right? It cannot necessarily do it better or worse. However, in the machine learning world, it can definitely be, that this thing here is like 90% accurate, which is already good, but then something comes out with 95% accurate, and that's better, and you would like to sort of switch to the better thing, or the thing that meets your needs more, the thing that works on your test data set, and so on. So that's sort of the case to be made for an AI marketplace. Now, this SingularityNet's vision is that, let's say, I'm a researcher, I come up with a new entity extractor, right? I have my paper here, I have it written, I have maybe a bit of code somewhere. What I can do is I can plug this into SingularityNet, right? And then I am, say, here, I am entity extractor X, and you can advertise yourself to this network. And then all the other nodes, like this text summarizer node, but many other nodes, could then come and sort of in an automated fashion test some sort of test data set that they have against you, right? They test it against your system, and they can evaluate you, and then they will switch to you, to using your code if you are better than the competition for them. Or maybe if you're cheaper, right? And for that, if you're a researcher and do all that, for that you would get money, because every time a node calls you, they're giving you some money for analyzing their data. So that is the core idea behind the AI marketplace right here. So the AI marketplace as a whole looks something like this. And there's a lot of stuff here, but we'll go through it sort of one by one. Okay, so it is, so this here, it mixes kind of conceptual and technical and so on. But ultimately, you have, is there a way I can draw this more easily? Yeah, maybe. Okay, so you have consumers, okay, and consumers can be people, or can be robots. And you have a whole network of them, right? And the robots, if it's a robot, the robot exposes an API, as we said. The robot exposes an API that says exactly what inputs it takes and what outputs it provides, and it can also do tags. So here are my inputs, here are my outputs, and it can have some tags. It can, for example, say, hey, I am an entity extractor. I do entity extraction in English, and so on. Though maybe the English would actually go into the input definition. So it could do entity extraction. So the input definition says I need a string that's called text, and that string needs to be language English. And for that, I can produce a list of entities. Entity. Something like this, okay? It is very much like you would specify an interface in regular programming, except that in SingularityNet, these types here, so the string with the language parameter and like the definition of what an entity is, they are, I don't want to say centrally because it's on a blockchain, but in essence, they are on the blockchain centrally deposited. You can add your own, but you can also implement the ones that other people have already defined. And what would be the good thing about not defining your own? Well, if this is the kind of commonly agreed upon standard for entity recognition, did I say augmentation? Extraction, entity extraction. I said I put an A all the time. Sorry about that. If this is the common definition for entity extraction, and you implement the same, right? You have your new algorithm over here, and you implement the same API. You have this green API, and you implement the same types. Then anyone who uses this API can, if they want, switch without any work to your API. And if you are better, then you get probably their business because they want to call the better one. The idea of SingularityNet actually goes further because this is not only callable by humans, this is also callable by other robots. So here I have a other robot, and this is a special robot because this robot is like an evaluator robot. So this robot can go around and it has a little data set inside of it, and it will just do nothing else but scan for new AIs on the network that implement a certain API. It will recognize and it will say, this is the API for entity recognition or entity extraction. I will simply run my test data set against it, and I will run my test data set against this and so on, and I will report. So my API will be, so input would be a task name. So task would be a string or something like this. And the output would be a list of model and performance, like model A, model M, 90%, model X, 95%. Okay, so there can be robots that test other robots and then publish sort of ranking lists, and then I as a human or the robot, the higher order robots, they can go read this robot and then decide to which of all the listed things they want to go. So at central core to this system is this kind of shared type system. If you share the types, if you share the APIs, your APIs become replaceable with one another, and therefore you can enable sort of automatic competition and automatic matchmaking. So these robots, there are evaluator robots and there are matchmaker robots, where you can tell a robot, I would like to extract some entities. Please find me the best node in the network that does it. Okay, and the marketplace makes sense because it's AI and it constantly shifts which one is good and which one's appropriate. That's the best case I can make for it. Like, I have my doubts that this is actually the case. Like, but actually, no, let's make the case against it. So my case against the AI marketplace as it is listed here is twofold. So first point against it, everything we know right now is end to end. The direction of research is clearly going into less structured data and more end-to-end. That means if I want to do a text or a document summarizer, I am right now much better off just training a giant model that does it end-to-end rather than using many, many small models. Because if I call an entity extractor, right, and I simply only rely on that information, I lose the rest of the text and the nuances in the text. I simply get the output of that model. Now, I could combine that, of course, but this idea of modularizing AI, right now, research is pointing into a different direction. And second of all, I still believe, if I make a product, if I build a product towards a user, I want to know what's in it. Like, even if I have to go myself and test the stupid API, I would never use like a matchmaking agent that dynamically goes and finds me someone who can implement this API, because implementing an API only goes so far. Implementing, like I require image and I output value, that's an API, but that can be many. And then, maybe these tags here, maybe these tags could do something, but it is not like, I think the system, even though it's, thought out well with the types and the APIs and so on, I don't think that's enough. I think that works for a very, very small subset of AI tasks. I don't think that works for most of the AI tasks that we have right now, because simply API definitions just don't convey what the models. So wait, API. So API does not convey what the model does. Function. In my mind. So I would ask yourself if you were there to use a matchmaking agent and then sell that product to a customer. It's shady. But I guess the goal here is that in the future these matchmaking agents will be much more intelligent and so on. Yeah. So here is how it works on a more sort of technical level. So there is two components here. There's off-chain and on-chain. So if I'm assuming you know what a blockchain is. If you don't know what a blockchain is, a blockchain is basically a distributed database and in some forms also a computation engine. So it's kind of a distributed computer that you can't fake, so you can't cheat. No one has authority over it. Everything is visible, and so that's secure. The drawback is you cannot do hardcore computation on blockchain. So this is not AI on blockchain. The blockchain is simply there to, first of all, register the AIs, so register the types, so this APIs here, and register what AIs are available in the network, and second of all, to facilitate the payments to the AI. So how does that work? It goes via this sort of multi-party escrow contract right here. So there's the registry, by the way. That's where AIs register and put their types. So that's one function of the blockchain. The other function is to escrow money. And this, if you know Lightning Network, is very similar to this. So what you would do if, I don't know, Alice wants to call Bob, Alice would sort of put a bunch of money, like a big bunch of money. How do I do that? Alice would send money to this escrow account, like this much money. And then that establishes a channel between Alice, and Bob. So there is a channel is opened, and it's tied to this money. And now Alice can sort of send incremental amounts of that money to Bob. And every time, one of these, like a little bit of that money is used up. And the reason you do it in escrow form and not, so all of these could be transactions on the blockchain, right? But that's, first of all, it's slow, and second of all, it's expensive. And if you do it like this, you actually only need you need one transaction in best case. So if Alice spends this much money to Bob, there needs to be only one transaction to putting all of it to Bob at the same time, rather than all these small transactions. So that's kind of the channel principle. I think, yeah, it's very similar to Lightning Network, and it's still secure. So it's still secure the way it is done. Don't want to go into channel economics and security right here, but suffice to say, you can make this secure and fast to a certain degree. Okay, so that's how it works. Every time you call an API, you just send it some money in order to call it. So how does this look? This looks something like this. Oh, sorry. Here is this AI marketplace. They've actually built it, and they have a bunch of services on there. As you can see, it's kind of, they take some standard AI tasks and they put them on here. And if you click on one, you can either pay AGI tokens. That's a thing we're going to get to in a second. Or I think you have like 10 free calls a day if you make an account. So I've tried it out. It works. But it's important to realize that the computation does not happen on the blockchain. You send money on the blockchain, and the AI service, it runs off-chain. So this is off-chain, okay? So it is not a secure AI. You still need to trust the thing you're calling, right? It's not about privacy that much, but you can't verify the outputs. You can't verify the computation as you could if it were happening on chain. Now, there are methods to sort of do heavy computation on chain, but these, I guess, wouldn't be that efficient. So just take that in mind. Now, the other thing is, I always say you send around money, but what you actually send around is a token. So a token is a very special concept. If you don't know what a token is, it's like money on top of money. So it's like if you go to a fair and the fair has like its own internal money system. At the beginning, you pay like $20 and you get 100 fair coins, and you can use the fair coins inside the fair, and that just enables the fair to sort of have its own monetary policy. And it's usually done with these projects to, at the very beginning, you sort of sell those coins to a lot of people, and the people buy it not because they can use it right there, but they estimate they can use it later, and it's a way to fund a project. It's called an initial coin offering usually, or initial token offering. The coin that SingularityNET uses is aptly called AGI, and there is 1 billion, and you can see here it's still active, so it's still being traded. You can see this is an hour ago, 15 minutes ago, and so on. If you look at here is analysis. If you look at the activity on the network, it had a lot of activity at the beginning. It dropped, and now it picked up a little bit again. I don't know exactly what that's related to, but so it is still alive. If you look at the price, however, this sharply dropped and is now actually below the price of the initial coin offering. And what you hope when you buy the initial coin is not only that you can use it later, but that since there's only a limited amount of tokens, that will be more valuable in the future, because people want to buy it off you because they want to use the network. Here, it sort of looks like that's not exactly happening, and we'll get to what they're doing against it right in a second. The answer is inflation. So in a new blog post, actually, as I was preparing for this video, this new blog post came out yesterday. And here they're announcing sort of the path forward, SingularityNET Phase 2. And essentially what they're doing is they're switching blockchains from Ethereum to Cardano. And I have my doubts. I don't know much about the whole crypto space, but isn't Cardano where massive amounts of the coins are like in some I think there are massive amounts that are just never moved and so on, and it's quite scary. But they probably know what they're doing. And with that, they are doubling the amount of tokens. Like, they could do it without increasing the tokens, but with that, they're issuing another billion tokens. I think 50 or 25% will go to themselves. So that's usually, you do that in initial coin offering, right? You keep some of the tokens to yourself because as people buy it, it's valuable, and that's how you fund the operation. So here they need to fund it some more, so they just inflate the currency with the new token. And they project that the network is going to be used a lot more than double now. So I guess if you buy the new tokens here, Phase 2 plan. 5 years from now, there will be 2 billion instead of 1 billion tokens. My strong assessment is that in this case, the overall value of the network in 2025 is going to be far more than twice what it would be if we didn't release the new token. So they need money. They inflate the currency. It's it's government. I guess it's valid, but just to be aware. Okay, that's the network. There are a few crucial components that I have left out now. But that's essentially how it works. So one crucial component, so here the registry is where you register. One crucial component is the reputation system. And this is something that's quite difficult. So the reputation system is important because if you want to sort of find agents that perform well, you can also sort of rely on reputation. So if a lot of people have bought services from a particular node in the past and they rate it high, then you can sort of trust that node more than if a node is lower rated or has dissatisfied customers. So they spent quite a bit here talking about reputation systems and how you could do them, and that is an open area of research. It's a really hard problem to make a good reputation system that can't be gamed and so on. There are various ways, like, for example, a stake deposited by a consumer or service owner to be forfeited should its rating in some dimension fall below a given threshold. So you can put some money and say, well, if my rating falls below a 3, then that money is gone. I will it's burned. It's automatically burned, and that gives people more trust in you because you're now forced to uphold that rating. But it also allows some kind of mafia games. Like, you could go to that service owner and be like, well, it would be a shame if you had a bunch of 1-star ratings coming in. And then you can sort of blackmail them in given circumstances. So it's not easy, right? It's not easy, but that's built into it. By the way, because this is on-chain, anyone can participate in the market permissionless, which is a really good thing. However, they maintain kind of a DApp, a centralized platform where they control. So you sort of have this decentralized thing where everyone can participate, but only some people are listed on the main hub, let's say. But you can technically build your own hub. Like, you can build your own Android app store and so on. So think of it like it's a marketplace for apps, but only the ones that are KYC compliant will be in the Google App Store, but you can build your own alternative app store. They also want to provide AI infrastructure as a service, and that, I feel, it's really irrelevant. Like, they say, okay, we want to provide this, but it really doesn't matter for the SingularityNET. So they here is where they go into, oh, you could do this, you can do that with it, and so on. You can deploy it on embedded devices. So their idea is really that the whole world will be connected to this network, and whenever you require any sort of functionality, you just call the network, and the network solves your problem. As I said, I'm kind of doubtful. I still think it's probably going to be people just build the functionality either into a custom, uni service, or they they just build it on device. So the last component here is democratic governance. So they are invested in sort of making this a community effort. And one thing is this governance, right? How do you govern a decentralized organization? And that is also an unsolved problem. They do it in multiple stages. So they say, okay, in years 1 and 2 of network operation, basically the foundation says everything according to any major changes the foundation decides. So the foundations are the maker of the network. In years 3 and 4, they transition. So major changes, agreement of the foundation plus a majority AGI holder votes. Minor changes don't actually even require the foundation. And then there's also this introduction of benefit tasks. So years 3 and 4, and from year 5 on forward, the foundation is gone, and it's only done by votes, or by AGI token holder votes, which are logarithmic, such that rich people don't have too much power. So this was launched in 2017 at the end. So technically, we are in this phase right here. And I have searched for like an announcement that, we're going to transition from this mode to this mode, but I haven't found it on their blog. Instead of what I found are like announcements that they're going to launch this supervisory council, which are like elected members that check the foundation. And also in this roadmap of part 2 that we've just looked at, they also saying, progressive decentralization, making it real. They also talk about this supervisory council, and they now pay them, and they release financial reports. But nowhere does it say that, see here, it's 3.5 years in, so they should be in that second phase. Maybe they are, but I would guess they'd make an announcement if that's the case. Maybe I've just missed it and they're actually doing this, but I have my feeling that if you launch such a system and you have power to do stuff, and even especially if the system doesn't grow as much as you expect and so on, you're not going to give that power away. So that is my doubt here, is that if you have the power, of course it's always better for you if you say, well, I'm just going to hold on to it a little bit longer. Eventually, when everything goes well, but it's never that everything goes well. Hello, communism. Okay, so enough rant. The benefit tasks. So they also have in mind, you see there's a lot of stuff in this network, right? They also have in mind that this network should benefit sort of humanity as a whole, which is, a laudable task. But they have a system where some tasks are classified as benefit tasks, and these benefit tasks, they are suggested by AGIs, by actors in the network so each agent gets a certain number of benefit votes, right, to cast each month based on its benefit rating. So the rating system is multidimensional. One aspect is the benefit rating. Someone can rate you beneficial if your AGI cures cancer or something like this. And then you nominate, you vote, and then some money goes to these benefit vote winners. Once a qualified benefit decider nominates a certain task, yada, 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 if 25% votes are cast in the affirmative, then the task becomes a benefit task. Once a task is a benefit task, any agent capable of performing it and possessing a sufficiently higher rating and benefit rating will receive benefit payment for doing it. Okay, so the idea is the community nominates beneficial tasks, and these tasks will get benefit payment. The only question is, where does this come from? Where does that money come from? The benefit payment. So I guess it has to come from other people. So you have to have some sort of a benefit tax or something like this that you of other transactions that you give to the benefit tasks. And then this is like the whole system works. There's nothing about this that makes it benefit specific. You can switch out the word benefit by evil. Like you have an evil reputation, and then some tasks are evil and get evil votes. And if you are especially evil, you get evil payments. This whole notion rests on the fact that people somehow recognize what's beneficial, which is a highly controversial, right? And it's basically politics, right? Every politician advertises themselves as beneficial. Every organic food is beneficial, but then you just do the bare minimum. You take 99% of tomatoes and you put a little bit of dirt on top of them, and boom, they're organic. Like, they're now labeled as organic. To me, this just seems like a thing that's going to be gamed so hard it's gonna become irrelevant. It's basically a political game at this point, because you cannot define benefit other than through human voting, and human voting is subject to money. And yeah, that's how politics starts. Okay, so they have a lot of examples. So here you see sort of this network idea. They have a lot of examples what can be done with this. I don't want to go into these because this video is already quite long, but it's a lot of talk. I just want to say that it's a lot of talk, and they're basically putting up everything they have done so far and they're doing on the network, what they can do with the network, which is all cool, right? But it's sort of advertising what kind of research they do on it. And yeah, the last point, yes, it's very long. So these people, for some reason, they're like two things they love, or three. There's graphs, domain-specific languages. For some reason, they love graphs and domain-specific languages. So their idea of AI, it all revolves around kind of classic notion of AI. So there is knowledge bases, and then there is graphs and you can see this reflection in SingularityNET, right? This idea that lots of things by themselves network together can make up a bigger AI and so on. That is exact reflection, and exactly goes counter to like the deep learning idea of let's do everything end to end. So the SingularityNET here is very much a reflection of what these people think. And yeah, for some reason they love inventing DSLs for new problems. Like, why? What? Like, I've never understood DSL aficionados, but I guess if you're having fun. Okay, so here they say measuring, modeling, and extending SingularityNET. Okay, so this is sort of their research on SingularityNET itself, which is quite a important thing if you build a system like this. But what I wanted to do, so I've read through all of this kind of research suggestions and what they're doing, and they just make it seem great, but it's also very washy, in my opinion. And I was wondering, is it just because it's a white paper and there's actual good research? And for most things, I can definitely guess. They're also the people behind this Sophia robot. I don't know if like this Sophia robot and so on. They have a lot of success, so precision medicine and so on. There's a lot of research, but some things just sounded also just washy. So here, this is something that made me particularly just kind of stop. So they want to measure with this phi quantity for measuring integrated information in complex cognitive networks. So this phi, this number phi by this researcher Tontoni, is sort of a fundamental measure of the level of consciousness. And they themselves say, maybe it's not the measure, but it's certainly an interesting measure and so on. And they say, we have experimented with measuring phi across time series generated by OpenCog. By the way, OpenCog is from the same person. That's one of the co-founders, Ben Goertzel of SingularityNET. OpenCog's attention allocation module, yada, yada, yada. While the system parsed and semantically analyzed a series of short documents, we have also calculated phi values while the OpenCog system controlled the Sophia humanoid robot as she led a person through a structured meditation system. So the extent of them describing the research is simply, we have experimented with it and we have measured it across time. And so I was wondering, like, what's behind this? So I went and I read the paper that's linked there. That's this: using Tontonify to measure the consciousness of a cognitive system while reading and conversing. And so this is a paper. It's quite short, but they let it read like texts from about different things, and they measure this phi quantity. And when you go and look first, what's this phi quantity? This is kind of one of these papers. It's very mathematical, actually, and there's a lot of information theory in there. So it has something to do with mutual information. There's a lot of ways you can calculate it, as you can see here on the left, and there's a lot of ways you can approximate it. So this is like a serious quantity, but measuring it is like super hard. And here they let this OpenCog system read short texts with respect to, as you can see here, poison and insects, and they look where the sort of, I guess, the attentional focus of the system rests on which of these concepts, right? And then they measure the phi over time, and their claim here is, we also calculated phi based upon the concept nodes, up here. As the system ingests each sentence, word nodes corresponding to each word are stimulated with this system, thus triggering attentional focus dynamics correlated with the reading process. One goal of the study was to observe whether after reading documents regarding insects, then poisons, attention would spread to the concept related to insecticide. This phenomenon did occur. So they say, okay, when you read insect and poison, after that you put a focus on insecticide. And you can see, so insect is blue, poison is orange, and you can see maybe the insecticide, bumping a little bit after while you read poison. But this could also just be because it's associated with poison. This is, I don't know, this is interpreted a bit too much into that graph. And then what's even more astounding, we also calculated phi values based on the concept node insect, poison, and insecticide. As figure 3 shows, there was an interesting jump in the phi value when insecticide first became important, suggesting that the phi increase was correlated with an increased complexity of attentional spreading within the atom space. So the atom space and so on, that's sort of this classic AI concept of knowledge bases and atoms. But here, so the claim is that the phi on the right somehow correlates with the insecticide attention on the left, or with anything interesting, and that to me is a stretch. In fact, I've put these things above one another. So in the gray background here, you can see the phi value, and I've matched up the time steps right here. And so the claim is that here insecticide marginally bumps up, and then sort of this phi spike is here. But if you look anywhere else, like here insecticide bumps up, okay, but much delayed spike, and here it doesn't bump up at all, but there's a spike still. And it just seems like that is just not a inference you can make right here. Like I'm not sure. Let me know what you think. But if you can't just nah. Sorry. This one, this one, it was the one that was kind of the most strange to me. But also, don't tell me that this does anything. But in any case, this is the type of research that they do, and so they measure the intelligence of the system and so on. The last thing is what they want to do is this OfferNet Economy. And in researching this paper, I have also watched a bunch of talks from Ben, and he seems like sprawling with ideas. And the talk about these OfferNets is also, so the idea behind it is that OfferNet is sort of an economy without money. The OfferNet's domain model, where is it? So, I don't remember where it said, but OfferNet is like an economy without money. So the idea behind it is, okay, person A, person B, person C, or machines, they are sort of in an economy, and person A wants something that person B has, but B doesn't want something that A has. Well, instead, B wants something that C has, and C wants something that A has. And the logic here is, couldn't you, A cannot trade with B, B cannot trade with C, C cannot trade with A, but they can trade in a circle, right? And this OfferNets, they do make this possible. And so the idea is sort of everyone puts out there what they want, and the OfferNets, they will sort of figure out who needs to trade with whom, and thereby you could make an economy without money, right? Without, you can make a money-free economy. And is this the right paragraph? Because there was a fun sentence. There was a fun sentence that I've seen right here. So this is another thing where I think that just like the ideas, they go a bit too far. OfferNets, analyzing the data, yada yada yada. Open-ended process. Okay, I don't know where it was, but they say something like, OfferNets could mediate this process, and how do they mediate this process? Such that everyone actually gets their worth of stuff that they put out. They mediate this process by means of the offer coin. Okay, so the offer coin is now transferred from B to A. Or from A to B, let's say, because A wants something that B has, and the offer coin is transferred from B to C, and then from C to A. So the offer coin makes all of this happen in an economic sense. And are you saying there is an asset going along with a certain service, and the asset is sort of agnostic, such that you can, if B gets the asset from A, B can then give the asset to C in order to obtain services from C, and that asset actually is what makes the whole economy work, even though no one directly wants to trade with each other, and you're doing all of that without money? That's crazy. So in any case, I think there we go. OfferNets. A decentralized economy providing an alternative to purely currency-based exchanges. This economy features a complex network of interactions that optimizes reciprocal changes of goods and services by finding agents with compatible and complementary preferences and coordinating their interactions ... by means of a coin, which is money. This is exactly what money does. That's what money is for. In any case, these people are very smart, and I'm probably too dumb to see what the exact difference is right here. So I just found it funny. if I'm completely wrong, then let it be stated that, that's what a only semi-smart person would conclude from reading these things. All right, this was lengthy, but I hope you sort of got the idea. The base system is an API marketplace. Now, the API marketplace in itself doesn't have anything to do with AI necessarily, but I've made the case that the API marketplace only makes sense in the world of AI, because if it was regular software, you would just hard code either the API calls or you would actually include the library. So the marketplace makes sense in the realm of AI. Okay, it's doubtable whether that's actually the case. It very much goes against the end-to-end principle. It bets on a form of AI that works on discrete graphs. It works on subcomponents divided into subcomponents. It works on networks built together to achieve higher order functions. It could definitely be that the future of AI lies in this direction. It's just that the current direction is pointing away from that. The whole marketplace runs on the blockchain, and only the marketplace. So the AI processing is off-chain. So it is not a on-blockchain AI. And yeah, they've built it, and they are in money problems currently. They're inflating the currency, but they're switching blockchains because they think the new blockchain will be better and faster. And they project high growth, and the token is actually active. So it's not a dead project, and they are in the news quite a bit, especially with this Sophia robot. I think that is it's a kind of a PR magnet. All right, that was what I had to say. I hope you enjoyed it. If you did, share it out. Let me know what you think in the comments. Let me know what I did wrong, and bye-bye.